Okay, so when we were looking at solving equations, we looked at some that required isolating the variable, and then we looked at some that were factoring. So for example, this one, you had to factor, we replaced the cosine with a different variable, we factored it, and then we solved it. You are going to get some questions that perhaps have two variables in them. So you'll notice that this question has a sine and a cosine. So we can't have that. That's like having an x and y in an equation, and you cannot have two unknowns when you only have one equation. So remember the trig identities from grade 11. We had our Pythagorean theorem identity, sine squared plus cos squared equals 1. So if you did the trig units in grade 11, you'll remember this. And then we could rearrange this for sine. So let's say we wanted to get sine by itself. We could move the cos squared to the other side. And likewise, we could do that with cosine. If we wanted to get the cosine by itself, we could move the sine to the other side. So the trig identities actually have three of them because you can rearrange the original one to get the other two. So what we can do is replace the cos squared. You can't replace the sine because it's not squared, and that's not the identity. So we could replace cos squared with 1 minus sine squared. So I'm just going to write it down here. And when you are replacing, just keep in mind that you should probably put it in brackets. Oh, come on. My smartboard's not moving. Okay, so when I replace the cos squared, I'm going to put it in brackets, especially because I have this subtraction or a negative sign in front. And that's going to affect the sign. So I'm replacing cos squared with 1 minus sine squared. I'm going to expand that bracket by applying the negative to both terms. So the 1's actually add to 0. And then I am solving, so everything has to be on the same side. And it has to be equal to 0. So I'm going to bring the 2 sine theta to the right side. And then I want to factor. Right? If I'm solving it, especially since it's a quadratic, I need to factor. So I see that there's a common sign. So I'll factor that out. I don't know why my smartboard won't move. So we have two factors. We set them both to 0. So we have one factor here, sine theta equals 0. So there's 1. And then we have one factor here, or 1 root, sine theta equals 2. So if you remember from a previous lesson, we knew that if sine or cosine was greater than or less than 1, that is an invalid root. So we don't have to worry about that root. So we just have to solve for sine theta equals 0. I didn't write an interval here, but let's pick an interval. So we'll just do between 0 and 2 pi. So we're going around once in the positive direction. So I'll do my cast rule. And obviously I can't use that because it's 0, and that means I'm landing on an axis. So my second option is to draw the sine curve over the interval 0 to 2 pi, and then see where it hits 0. So it hits 0 at 0, at pi, and at 2 pi. So that is my solution. So theta equals 0, pi, and 2 pi. Okay, so the only difference in this question and the one we did the other day was that we had two variables and we had to replace one of them. We did that one. Okay, so similar to this one, we have 2 cosine theta minus 1 minus sine squared. I cannot have cosine and sine in the same question, so we would replace the sine squared, because we can't replace cosine, but we can replace sine squared. And let's apply that bracket. So it gives me that. And then we get a similar question or similar function to what we had with the other one, but this time it's cosine. So we'll factor out the cosine. You'd think I would have been able to pick a different question, but that's okay. And so we get two roots. Cosine theta equals 0. Cosine theta equals 2, which is also invalid. And so we're solving for cosine theta equals 0 over the interval 0 to 2 pi. So we'll just sketch that cosine curve between 0 and 2 pi, and we see that it hits 0 at pi over 2 and 3 pi over 2. So that is my solution set. So not much different than the ones we did on Monday. It's just that we have to replace one of the variables so that we have only one variable. Okay, the second thing I wanted to look at was double angles. So this can be a little tricky, not at the beginning, but when we're graphing. Okay, so double angles, think about double angles as an angle that has been horizontally compressed. So if I say sine 2 theta, which is called a double angle, that is the sine theta function that has been horizontally compressed by a half, and likewise with the cosine 2 theta. So we do have some trig identities that are double angle identities. Okay, so sine 2 theta, the identity that has already been proven is that sine 2 theta equals 2 sine theta times cosine theta. Cosine 2 theta actually has three versions, so similar to the trig identity that we just used in the previous question. Cosine 2 theta equals cos squared theta minus sine squared theta. But we could also replace this with 1 minus sine squared theta because we know that's equal to be true, or we know that's true. So that gives me the second version of a double angle. So it could equal cos squared theta minus sine squared theta. It could also equal 1 minus 2 sine squared theta if I replace the cos squared theta, and then I could also replace the sine squared theta with 1 minus cos squared theta, and that will give me 2 cos squared theta minus 1. So there are three versions of the double angle for cosine, only because we could replace the cos squared or the sine squared depending on what we need. So you can use any of the three, depending on which one is most useful, especially when we're doing trig identities in Unit 14. Normally or usually one of those versions will be more useful than the other. Okay, so you'll get a similar question we had earlier in the unit. We have been given sine x equals 4 over 5, and it gives us the quadrant that we can find x. So we're going to start by drawing a diagram. It is in quadrant 2, because it is between pi over 2 and pi. So that's where angle x is. We've been given the opposite side and the adjacent, or hypotenuse, because we have sine. And then we would use Pythagorean theorem to find the missing side. So just like we did with the other question, we could find the value of b, or the value of x, and it is negative because it is in the negative part of the x-axis. Okay, so you're going to draw your diagram, and you're going to find the missing side. Then we're going to find sine 2x. So we're just going to change sine 2x to 2 sine x cos x. And then we're going to look at the diagram and find those values. So sine x is 4 over 5, and cosine x is negative 3 over 5. And then we're just going to simplify. So it'll be negative 2 times 4 is 8, 8 3s are 24, and 25. Okay? And then it's also asking you to find sine 2x. Does not matter which version you use, you'll get the same result. So I'm just going to use, I'll just pick one. So I'm going to use 2 cos squared x minus 1. Cosine is negative 3 over 5. Oh, come on. And then we'll just simplify this. So negative 3 over 5 squared is 9 over 25, which gives me 18 over 25. And then if I want to subtract 1, I'll need a common denominator, which would be 25. And so 18 minus 25 is negative 7 over 25. Just to show you that it doesn't matter which version you use, let's use a different one. So let's try 1 minus 2 sine squared x with the same question. So sine x is 4 over 5. So it's 16 over 25, which is minus 32 over 25. So we have 25 over 25 minus 32 over 25 is negative 7 over 25. Okay, so it doesn't matter which version you use of cosine 2x, you're going to get the same answer. So that's just a straightforward question. It gives you an angle, it tells you what quadrant it's in. You're going to draw your diagram and find the missing side, and then you're just going to find sine 2x and cos 2x. Okay, so here's a similar one. So this one says sine theta is 12 over 13. So that's the opposite side in the hypotenuse, and theta is in quadrant 1. So theta is in quadrant 1, and we are given 2 sides of that triangle. We would find the missing side. And B will work out to be 5. Okay, so I've got my completed diagram, and then I'm just going to find sine 2 theta. So we'll use the version 2 sine theta cos theta. Sine is 12 over 13, cosine is 5 over 13. And then we just simplify. So 2 times 5 is 10, times 12 over 169. If you can reduce it, great. If you can't, just leave it. Okay, and then cosine 2 theta, I'm just going to pick one of the versions. So I'll use the 2 cos squared theta minus 1, and cosine is 5 over 13, which is squared. And so we get, let's reset. We get 25 over 169, which is 50 over 169, and then we'll change 1. 25, 5 5 is 25, 2 5. Why am I getting a different answer? Oh, because it's a different question. All right, so that leaves me with negative 119 over 169. Okay, so the other part of the question, which we did not do in the previous question, was determine the quadrant of the angle. Determine the quadrant of the double angle. I know that the single angle is in quadrant 1, right? It said theta was in quadrant 1. But it didn't tell me which quadrant the double angle is. Okay, because remember the double angle, it's compressed, right? The graph that's sine theta is now compressed by a half. So I have to figure out what quadrant the double angle is in. So all I'm going to do is use my cast rule. It's not too difficult. Sine 2 theta is positive, right? So sine, the double angle for sine is positive. So when I look at my cast rule, it would have to be in quadrant 1 or 2 because it's positive, okay? Then I'm going to look at my cosine theta. Well, cosine of the double angle has a negative result, which means it can't be in quadrant 1, it must be in quadrant 2. So the double angle is in quadrant 2. So the single angle is in quadrant 1. It told me that at the beginning. I've compressed the graph. The double angle is now located in quadrant 2. Okay, so you just use your cast rule to determine that. Look at the first answer. That will narrow it down to 2 quadrants, and then look at the second answer, and then that will narrow it down to 1 quadrant. Okay, so now we're solving. So I want to find, I have a double angle sine 2x equals 1/2, and I want to find the value for x. So this is similar to how we solve sine x equals 1/2. So this green line here, I've just graphed it. So this green line here is sine. So if I wanted to look at the graph and figure out where sine x is 1/2, well, here's a half. So there would be an answer here, whatever that may be, and there would be an answer here. So when sine x equals 1/2, there are 2 solutions. And think about how we normally solve this. So if sine x equals 1/2, I would draw my cast rule, determine what quadrant it's in. It's in quadrant 1 or 2. So this answer is quadrant 1, and this answer is quadrant 2. And then there are no answers in quadrant 3 and 4 because the sign ratio is positive, and quadrant 3 or 4, the sign ratio would be negative. So these are my 2 results for sine. If it's a double angle, so now I've compressed my graph, right? So this sine curve has now been compressed by 1/2, so I'm going to get it in twice in this interval. And so if I look at this, there are 4 answers, right? There's one here, and then there's another one here, and another one here. Because now I have the graph in twice, I'm now going to have 4 solutions. Well, how am I going to find those 4 solutions? So graphically, I'm just going to show you graphically what I'm going to do, and then we're going to do it algebraically. Okay, so we're doing this over the interval 0 to 2 pi, right? That's what the question says. Find x in the interval 0 to 2 pi. So here's 0 to 2 pi for sine, just for sine. So it goes 1, -1. So it goes. So there's sine. I can see that the compressed graph occurs twice. So I'm going to draw this sine curve twice, which means I'd have to go to 4 pi. So if I were just doing sine x, I would have to draw it twice to get 4 answers, right? So here's a half. So in order to get 4 answers, I would have to draw it twice. So I would have to draw the graph from 0 to 4 pi, and then once I got my answers, I could then compress it between 0 and 2 pi. So this is what I'm going to do algebraically. I'm going to find the value of sine x equals 1/2 as I normally do from 0 to 2 pi. But I'm going to repeat the graph so that I get 4 answers. So I'm going to, instead of going from 0 to 2 pi, I'm going to go from 0 to 4 pi. And then once I find those 4 answers, then I'm going to compress my graph so that it's over the interval 0 to 2 pi. Okay? So the green line is going to be doubled. And then once I find the answers, I'm going to squish it in and get my 4 answers from 0 to 2 pi. Okay? So we're going to solve. We're going to solve sine just x equals 1/2 over the interval 0 to 4 pi. Okay, so we're going to double the interval. Right, so that's what I'm doing. I'm doubling the interval. So I'm just going to solve this as I normally do. Sine x equals 1/2 in quadrant 1. And in quadrant 2, I'm going to determine my related angle would be pi over 6. So this angle's pi over 6. This angle's pi over 6. And then my solution set would be in quadrant 1, it's pi over 6. In quadrant 2, it's 5 pi over 6. But remember, I am going to 4 pi, so I have to repeat that. So graphically, I'm just going to erase this for a minute so that we don't have the red. So some of you are visual people and some of you just like formulas. 4, so let's make that 2, this 1. It's not the best. Let's fix this so it actually looks a little accurate. So make that 1, 2, 3, and 4. Oops. That's not what I wanted. Okay, so that's just a sketch. Okay, so there's my graph 0 to 4 pi. So I have just found, and here's 1/2. So I found this answer is at pi over 6, and this answer is at 5 pi over 6. So if I do it the normal way, I found pi over 6 in quadrant 1, 5 pi over 6 in quadrant 2. But remember, we're doubling the interval, so these are going to repeat. So this pi over 6 is going to repeat here. So we're going to add 2 pi to that pi over 6 to get that next answer. So pi over 6 plus 2 pi is going to equal 13 pi over 6. Okay, so that would be this one. If you're thinking about it in the quadrant, I'm going all the way around plus back to pi over 6. So pi over 6 and then go all the way around back to pi over 6. And then this number is being repeated here. Right? So we're going to add 2 pi to 5 pi over 6, which will be 17 pi over 6. So again, if you're doing it on the quadrant, you're going around all the way around, then back to 5 pi over 6. So you're adding 2 pi because it's going to repeat. It's periodic. So those are my 4 answers. Pi over 6, 5 pi over 6, 13 pi over 6, and 17 pi over 6. But remember, that's for sine x, and we want sine 2x. So now, you want to find sine 2x. We're going to compress our solutions by 1/2. Okay, so the double angle would be, so pi over 6 is going to be multiplied by 1/2, so it's pi over 12. And the same with 5 pi over 6 would become 5 pi over 12, 13 pi over 12, and 17 pi over 12. So that's what these 4 answers were. I'll go back to the very beginning. These 4 answers are pi over 12, 5 pi over 12, 13 pi over 12, and 17 pi over 12. So just to recap, what we did was we said there's going to be 4 solutions. So we're going to stretch the graph, just the regular sine x, and we're going to double the interval. So we're going to get the graph in twice, and we're going to find all 4 answers. We're going to find our regular answers by doing the way we've learned, and then we're going to add 2 pi to those 2 solutions because they're going to repeat. And then once we have those 4 solutions, we're going to compress them by 1/2. So we'll just multiply them by 1/2. Okay, you'll get the hang of it once you do a couple. Okay, let's do, we've got about 10 minutes. Let's do one more. So it might not always be just a double angle. It could be a triple angle. Or it could be cosine. So I'll kind of streamline this. Okay, and it's also doing a different interval. It's saying do it from negative pi to positive pi. So here's sine x to just pi, and then to negative pi. So if we're looking for 1/2, there will be two solutions, right? To the right, there would be two solutions at 1/2. There are none to the left. But we want to horizontally compress the graph by 1/3. So now we're going to get the graph in 3 times. So 1, 2, and 3. So now we're going to have 6 answers. Right? Instead of 2, we're now going to triple it. We're going to have 6. We're going to see that answer 6 times instead of 2 times. So what we're going to do is we're going to find sine x, just the regular x, as 1/2 over the interval negative 3 pi to positive 3 pi. So we're going to triple the interval. So sine is positive, we said in quadrant 1 and quadrant 2, opposite over hypotenuse. So our related angle is pi over 6. Just use the same. So my solution is 5 pi over 6 and 5 pi over 6. So if I go, remember I'm going to 3 pi to the right. So 1 answer, pi over 6. 2 answers, 5 pi over 6. 3 pi would be all the way around plus another pi. So these answers are going to repeat. So we're going to have 2 pi plus pi over 6. So think about this visually. I just found this one to be pi over 6 and this one to be 5 pi over 6. These are going to repeat. Right? So these two are going to repeat to the right. I can see them again. So I'm going to add 2 pi to pi over 6 and 5 pi over 6. So that would be 13 and 17. We also want to go to negative 3 pi. Well, first of all, when I go to the left, I see there's only 2 answers. And why is that? Well, that's because there are no solutions. Oh, stop it. No solutions on the bottom. I'll just draw it again. So now we're going in the negative direction. So this is pi over 6, and this is 5 pi over 6. So going in the negative direction, we have one answer here. This would be negative 11 pi over 6. Right, because we have pi, so this would be negative pi plus negative 5 pi over 6, right? Because we're going in the negative direction, so we're past pi. So we're adding the 5 pi over 6 to the negative pi. And then this one all the way over here would be, this would be 7, negative 7. And then the last one would be negative 11. The reason we don't have 4 answers to the left is because when we go around again to 3 pi, right? So here's negative 2 pi. If I go to negative 3 pi, it goes to here. Well, there are no answers in the bottom, right? There's no answers in quadrant 3 or 4, so I don't get another 2 like I did in the top. And I can see that here in my graph. This answer here gets repeated here, and this one gets repeated here, but there are no answers at the bottom, right? So I'm going to go pi over 6 repeated this way, and the same with the 5 pi over 6. So once I find my 6 solutions, we're going to compress by 1/3 because we wanted 3x, right? So my solutions for x are now compressed. So my solutions for 3x will be compressed. So I'm going to multiply these answers by 1/3. So it might seem a little tricky, but it's the same sort of thing. You're going to extend the interval. So whether it's a double or a triple interval, you're going to find your answers like you normally would over that interval, and then you're going to compress them. Is the 3 steps. Okay, we can look at some more later, probably on Friday when you're actually in the classroom. But that's double angles. I just want to also note there's a question or an example in the guide that I really hate, that I don't want you to do. So let me pull it up here. So you can just put an X through this because it's just confusing. It's just going to confuse you. So let me find it.